Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about DAC interfacing with 8051. So, DAC is a digital to analog converter, right. So, the number of binary bits will be converted into the specified waveforms. One of the analog signal is a continuous signals. So, this DAC mostly used to generate the different waveforms, either triangle waveform or sine waveform or square waveforms. Okay. So, here how we are converting, what are the steps are included for converting the digital to analog conversion, okay, with 8051. So, for this digital to analog conversion, we have one of the IC which is name it as 0808. Okay. DAC is a digital to analog converter. This IC number 0808 is used, okay, which are designed with the binary weighted R2 or ladder method. R2 or ladder method means in horizontally resistance or resistance, then 2 or, this is a 2 or resistance, this is R. So, this structure will be repeated based on the number of bit positions. So, this concept is used to convert the given digital signal into analog signal. So, this might be, you can consider this as a D0, then D1, D2, that way we are considering. So, this IC mostly available with the 8 bit IC or 10 bit or 12 bit. So, based on this only we can define the resolutions. Then this digital to analog mostly used to generate the different waveforms like a square wave, triangle wave and sine wave. Is a binary weighted R2 or ladder method means that structure is used. Okay. So, here we are finding the I out, the I reference signal into the corresponding bit position divided by the position, that is D0 by 2 power 1, D1 by 2 power 2 plus D2 by 2 power 3 plus D3 by 2 power 4 plus D4 by 2 power 5 plus D5 by 2 power 6 plus D6 by 2 power 7 and D7 by 2 power 8, its binary values. Okay. The corresponding bit also represented as D0 by 2 plus D1 by 4 plus D2 by 8 plus D3 by 16 plus D4 by 32 plus D5 by 64 plus D6 by 128 plus D7 by 256. Okay. So, based on this calculation only we are started to convert the given digital signal into analog signal. Suppose my data is FFH. Okay. FFH means what it will do, all bit positions will be 1, right, D0 to D17 all are 1. So, you will get the value as I reference into 255 divided by 256, because we are taking the LCM value. F of its corresponding decimal equivalent is 255, right, 255 by 256. Suppose if I am taking the reference current as 3 milliamps, this is a 3 milliamps, okay, then your calculation is 3 milliamps into the fraction value of 255 divided by 256 is 0.966. So, you will get it as 2.98 milliamps. This is the I out current. So, the corresponding voltage, suppose if you want to calculate it, corresponding voltage means V out. V out is equal to I out into R, or you may consider 5 O. So, 5 into 2.98 milliamps. This will be the voltage of our required FF value. Okay. Suppose if I am taking the value 45 H. So, 45 H means the corresponding ones and zeros, right. This value is 0, 1, 0, 0, 0, 1, 0, 1. So, based on that, what are the bits will be on D0 become 0. So, D1 means 1 by 4. So, this term, right, you can write it here 0, 1, 0, 0, 0, 1, 0, 1. Now, you can get what are the values are available, 1 by 4 plus 1 by 64 plus 1 by 256. So, you take the common LCM 256, okay. Then here 64 plus 16 plus 1. So, you get the value of 81 by 256. Okay. So, this fraction value was 0.316. Suppose you are considering the same milliamps. So, 3 into 10 to power minus 3 multiplied with 0.316. This is a V out value. Okay. So, based on your required given number, what is your digital value, you get this V out. V out represents the magnitude of your wave. So, either if you want the particular magnitude, you can initialize your digital value. So, now we will discuss about the DAC IC, which is 0808 IC. So, what it represents? It has 8 signals, right, because that is the input D0 to D7. Okay. DAC 0808. Then we are getting the V out, which is a analog signal. So, this analog signal is very less value. So, we are using the op amp to convert or to amplify the signals. Here we are using the 5 kilo ohm. So, this is the actual analog output we are getting. So, the each value of digital will be compared with that value, whether it is lesser or greater. So, after that only it will consider, that is why we are using the V reference value. With respect to the V reference only it will compare and take it. Okay. Whether the voltage is less than the V reference, we are considered as a 0 value. When it is higher, it will be considered as a 1. Okay. So, this is a simple facilities in DAC IC 0808. Now, we will discuss how to interface with the 8051. It is a 8051 microcontroller. Okay. So, this D0 to D7 is connected to the D0 to D7 of DAC. So, the required input we are getting, then it will be connected with a, either you can use base resistance along with a feedback resistance. This is the operational amplifier. Okay. Here we are getting the V out. Here we are giving the reference voltage V reference. Okay. Suppose you are connected with the port 0, means port 0 D0 to D7 is connected. The remaining power supply signals that are default 1. Okay. So, whenever you are connecting the output signal P0, your own digital value, either FF or it will be 45, right. So, based on that it will convert and give it as a waveform. Okay. Now, we will start to write the program. Physically we made the connection. So, based on the program only you will get the analog value or analog signal in the form of either triangle waveform or square waveform. So, first we will consider the generation of the triangular waveform. Okay. So, triangle waveform means it is like okay. So, how we are started to do this? So, initiate the value was 0 0 first, right, then we have to increase to the maximum value, either you can give it to the FF value. So, 0 0 to FF it increase, then it comes to the 0 0, then again goes to the FF value. So, the same process we have to repeat it to get the triangle wave. So, for that what we have to do? First I have to initialize the starting value A comma 0 0 H. Okay. After that which port you want to use it, means suppose in case of port 0 you can move to the port 0, port 0 comma A, right. Okay. So, after that call delay. Increase the accumulator value, right. So, after starting to increase your accumulator value 0 0 become 1 2 3 up to how we have to increase up to FFH, right. So, I will use the compare and jump not equal to the accumulator with the FF value. Okay. So, this value, the accumulator is increased from 0 to 1, then 1 to 2 up to FF. I want to repeat the process to rise the signal. Okay. So, I will give it here as rise, rising period, that is why I have given the rise. Okay. So, from 0 to FF it started to run, the value 0, then it increased, then up to FF the process is repeated. Okay. Now, it reached the value FF, what you have to do now? It has to decrease, right. Now, so now you can give the value, the same thing you can give it and the same port. Now, the current value is moved to P naught comma A, which is FF value is moved, then you can use the call delay, then decrease accumulator, right. So, how long we have to decrease? Till reach the value of 0. So, the accumulator value will compared with the 0 0. This is a falling period. So, I will give it as fall. Okay. So, what will happen now? From FF to 0 0, it is rotated, right. So, this same thing if you want to repeat it, then here you have to give short jump to this pointer, the starting line, or again or repeat you can give it. So, this is a way we are starting to develop the triangle waveform generation. First you initialize the 0 value, then move to the port, then increase till reaching the value of FF. After reaching FF, now you move the same value to the corresponding port, then decrease till reach the value of 0. The same thing is repeated for generating the continuous wave. Okay. So, the delay why we are giving is to get the proper frequency, we are initializing the delay, otherwise it will get like this kind of triangle waveform also. So, that is why we are initializing the delay. Delay, suppose if you want to initialize the delay for 1 millisecond, for 1 millisecond means what you will do? 1 millisecond divided by 1.085 microsecond, already we have discussed. So, based on that I will get the value of 11, which is 8 bit only. So, I will take it as 256 minus 11, 245, its corresponding hexa equivalent is F5. Okay. Now, I will start write the delay program for this. So, move the record your delay value for 1 millisecond, right. So, you can use any one of the register R1 comma F5, your record delay for 1 millisecond. Then decrease jump not equal to 0 of R1 to where means here the same line itself you can repeat the process. Then you give the return instruction to return back to the main program. Okay. So, you calculate your own required delay value and load it into this. So, based on the delay only how you are getting the triangle waveform is depends on like this. Okay. So, this delay how much you need, how to be initialized in the program. So, now we will discuss about the rectangular waveform generation. The square waveform generation is very easy. So, how we are doing square waveform means what it represents, the on and off periods are same. Suppose I am asking you to 1 millisecond for on period, 1 millisecond for off period. So, the same program first I will write how to give the square waveform, then we will convert into the rectangular waveform. So, for that, so move right A comma, you can initialize the initial value 0 0 h, then move port 1 comma A, right. What it represents, the 0 0 value is moved to port 1. So, all the values are 0 0. Now, you can call the delay, for 1 millisecond. Now, 1 millisecond delay will be on the low period, right. Again you want to high. So, instead of giving a 0 FFH, okay, I will give it the value of CPL. CPL it represents automatically, it will complement the accumulator. So, 0 0 become FF. So, now FF value again it has to move to the value. So, I will give a short jump. So, now FF is moved, right, same delay will be used and we are rotating, right. So, here the delay program is simply you can use move R naught comma F5 already we have discussed, right. Then decrease and jump not equal to 0 of R naught, then return. So, this way you can write it, or this is a program for generating a 1 millisecond of delay. Now, I am asking you to generate the rectangular waveform. Rectangular waveform means I just I ask 1 millisecond for off period, 2 millisecond for on period, then 1 millisecond for on period, 2 millisecond for off period. So, the pulse width of on and off is varied. Okay. So, now you think what are the change we have to do in the main program. This is a square waveform. Okay. In this I initialized the value 0 0, then it moved to port 1. Now, I have to call the delay for 1 millisecond. Okay. Okay. I get the value of 1 millisecond. Then what I have to do after 1 millisecond, now it goes to high value because I have complemented. Now, I have to give the another delay. So, here you replace this line. After getting f of value, I used to call delay of delay 1 or this delay for 2 millisecond. Okay. So, after that what I have to do, after complementing the same delay I have to wait, then it goes to the move to this, right. You can give it as a short jump to repeat. You can give it as repeat here. Okay. So, what it represents here, you are giving the value 0 0, then you are waiting for 1 millisecond, then complemented to FF, then waiting for 2 millisecond, then again it goes means here you have to give repeat. Now, again we are starting with 0 0, right, till this we have completed. Now, again 0 0, so it come to here, then we are waiting for 1 millisecond, then goes to high by complementing the value, then waiting for 2 millisecond, then it repeat the process. Okay. So, this is a way we can change your square program in square wave generation to the rectangular wave. Rectangular wave is one of the square wave only, but the on and off period width will be varied. Okay. I ask you to generate the waveform like this kind of rectangular waveform, 5 minutes 5 milliseconds delay on the off period, 2 milliseconds for on period. Okay. So, what will happen here, you are connected with the op amp. So, here I have connected one of the CRO to check the waveform. Okay. Then remaining physical connections you are doing. So, here before starting the program. So, how we are writing the program means just move a comma 0 0 h, then move to the particular port, suppose P1 comma A, after that call delay for off period, right. Then you can complement the accumulator, move to P1, then call delay, this is for on period. Okay. Then you just repeat the process by short jump. Okay. So, from here to here it is jumping, we are getting the value of 0 and FF, right. So, this is a on delay, off delay, only two different delays we have varied. Okay. So, now we will discuss how to write the delay program or how to calculate the delay value. In case of 5 milliseconds, the 5 milliseconds divided by 1.085 microseconds. Okay. So, its division value was 1843. Okay. This is a 4 digit number. So, I will take it as a 16 bit counter 65536. So, find the subtraction, then find the difference which is the value of 63693. Okay. So, you convert this into the hexadecimal, you will get its corresponding equivalent F5 CD. So, this is one of the value we have to load it for 5 milliseconds. Okay. For 3 milliseconds the same thing you have to use it, sorry 2 milliseconds only, right, 2 milliseconds divided by 1.085 microsecond. So, after getting I get the value was 4608. Okay. So, this value also subtracted from 65536, the difference is 60928. Okay. This 60928, just I will do the process how to convert into hexadecimal for this 2 milliseconds. So, after that you get a 0, then 808, the difference is 0, again you convert into divide by 16, then you get 238, then 0, then again you divided by 16, now you will get 14 and the remainder is 15. Okay. So, by this you have to write it as EF00H. So, its corresponding equivalent is EF00H. Okay. You take the T naught register for initializing the counter value for in case of 16 bit delay. So, I will take it as move, this is the delay program, move T L naught is equal to 00H, move T H naught equal to EFH. Okay. So, after that what we are doing, we are setting the timer. So, set bit of timer run. Okay. Then jump not below till the bit set of timer overflow flag. So, once you are initializing the delay in the timer, okay, so we have to run the timer. So, we are started, then the process will be continued till the timer overflow is occur. So, once the timer overflow is occur means then you have to clear the TF naught and clear the TR naught. That is, we are clearing the overflow flag and also we are resetting the timer start. Okay. So, by this way we can initialize the delay. So, this delay for 2 milliseconds I have written, the same program we have to repeat for the 5 millisecond. In today's session we have discussed about what is DAC, that is a digital to analog converter, that is defined by the 0808 IC. That IC is made up of R to 2R ladder method, the conversion techniques, then only we can identify the resolutions of the conversion. Here we have discussed about the 8 bit DAC. In this, the analog signal, that is the digital signal is given from the microcontroller, then the 0808 IC will convert and it will give the analog output which is very less value, that is why we are additionally adding the operational amplifier. That value will be, it will give the amplified signals. Then what kind of waveforms you want, either in the square waveform or in the triangle waveform or in the rectangular waveform, you have to write the program. How we are initializing the delay also will give the milliseconds your required delay for your waveform. Okay. So, I hope you understand, and I think you can create any kind of waveforms with your specified frequency or your delay.